one person used to manage, in some cases, tens of devices or maybe hundreds of devices, to networks in which a single person can manage thousands or tens of thousands of devices just because of the level of software automation, okay? So software automation, yes, it's changing networking, but it's not just changing networking. I mean, we see it today with self-driving cars, with manufacturing being completely impacted by software automation. So I would actually say that this is kind of a larger trend of software automation changing a lot of industries, and networking is not really an exception to that trend. Okay, so let me give you one quick. So since we have that requirement for making our networking devices easy to automate, and it has to be done through software, we want to make sure that the platform or the networking device provides a strong programmability functionality. And this diagram kind of summarizes how we built the components that make that programmability stack to automate devices and automate the network. The first part in the bottom is the basic infrastructure of all automation is going to be data models that is specified in a language that is called Yang, and I'll show some examples of that later. And those models are basically going to describe all the configuration, operational state, plus commands that you can run on the device, okay? So it's a formal specification. It's the data model defines basically a tree structure in a formal language of, again, all the configuration, all the operational state, and all the commands that can be run on the device, okay? And then you can interact with the box making use of those data models. To interact with the device, you need to interact over a certain transport. You need to encode the data that you're reading and writing in a particular encoding, and you need to use some protocol to communicate with the box, okay? So in our platforms, we have a combination of options. So actually, we try to be very flexible. You see here that you have multiple options when it comes to transport, to encoding, and protocol, okay? So this allows you to write software off the box and communicate with the device and leverage these data models, okay? We have a lot of options here in protocol, encoding, and transport. Excuse me. I just came back from Berlin Cisco Live, and I got a really bad cold, so I apologize. I'm going to be coughing a little bit throughout the presentation. Okay, so on top of all these options, we give you a layer of APIs to simplify the development of applications that can automate devices and ultimately automate the network, okay? And that's really the focus of our presentation today, those APIs. I'm going to maybe talk a little bit about the protocols, encoding, and transfer, but that's not really the detail. What you have to take away is, again, you have a formal definition in terms of data models, what the box can do, what kind of configuration it supports, what kind of operational state, meaning counters and statistics, and what kind of commands it can be run. And that information is available to you in the form of data models. And you need to interact with the box, and you interact using a combination of transport, encoding, and protocol, and you're going to have APIs that allow you to abstract all that, and it will make it easier for you to interact with the device, okay? By the way, I welcome questions at any point, so feel free to interrupt me if people have any questions, okay? So let me talk about a little bit of the logic that we put behind that programmability stack that I just covered. The first thing is that we wanted to make sure that it was completely based on data models. Historically, for those of you who maybe have less networking experience, people always interacted with networking devices using CLI, command line interface, right? And every time you tried to do automation, you would do automation with command line, right? Command line is not the best way to automate. It's complex to write automation software. You can do automation with CLI, but it's significantly more complex because it doesn't have a well-defined structure for automation, and it's not very computer-friendly. Command line is basically more human-friendly, and it's not necessarily very computer-friendly. Data models, on the other hand, are more structured in their definition. They have a formal definition. There's a specific syntax and semantics of each data model, and they are more computer-friendly. So they build an infrastructure already that's going to make it easier for you to build any kind of automation software on top of that device. When we build this programmability infrastructure, we also made sure that we could support different types of data models. The device ships with a large number of what we call native models, that are models that are very specific to the specific OS and to the specific platform in some cases, okay? However, in some other cases, people are looking for third-party models that are maybe vendor neutral. So we're going to give some details later about some of those models. And in particular, we support the OpenConfig data models that are vendor neutral. So again, we wanted to make sure that not only the whole infrastructure was built on top of models, but we were able to support multiple ecosystems of data models. The third key principle we wanted to apply was to really make sure that the models were decoupled from the choice of transport, protocol, and encoding. So it doesn't matter, as you saw in the previous slide, we have different alternatives to interact with the box. Regardless of what you choose to interact with the box, you're still going to be able to use the same data models, and you're still going to get basically the same data represented in a slightly different way, but you're basically getting the same data. The next key principle that we wanted to apply was to really give as much choice as possible in terms of transport, protocol, and encoding. Why is that? Different customers have different automation platforms. They use different kinds of tools. Not always you can get one size that fits everybody. You go to an ice cream store and you have strawberry, chocolate, vanilla because one flavor would not cut it, right? You would not open an ice cream store with a single flavor. For me, chocolate is enough, but other people still insist in strawberry and vanilla. So you definitely need to have other flavors, okay? Choice is good, but choice can lead or leads to complexity. When you have too many choices, it can become complex to choose which one is best for you, or you want to be able to abstract all those choices and kind of use the best of them without necessarily getting lost in the details. And that's the key principle between the APIs. Give you that level of abstraction and simplification that even though you have a lot of choices in terms of transport, protocol, and encoding, a lot of that stuff is going to be completely hidden away from you, so it makes it significantly simpler to write automation software. The last point was to really be pragmatic in how to balance between standards-based and open source. Historically, in networking, there's been a strong focus on everything being standards-based. And in the cloud and web provider environment, there's a strong, sometimes a very strong, or I would say in the compute world and cloud, there's a strong focus on open source. So recently in networking, there's been a little bit of a debate on what's the role that standards play and what's the role that open source play. We can lead that discussion and people can continue to debate that for years. For our solution, we just decided to be very pragmatic. Whenever there's a good standard-based solution or component or technology, we'll use it. Whenever there's something open source that is good, we'll go ahead and use it. So we're going to see that, for instance, in the previous slide, and let me just go back for a second. Most of, for instance, SSH, HTTP, of course, are standards. XML and JSON are. But for instance, we got here something called gRPC for a protocol, and we're not going to go talk about the details on that, but gRPC stands for Google RPCs, and that's one of the options that you have to configure the box, for instance. That's not a standard-based technology, it's an open source technology. We see here another component, GPB, Google Protocol Buffers, that is a way to encode data and exchange it with a device. That's not standard-based, that's open source also. So we adopted it whenever it made sense. So it's a very pragmatic approach. Any questions on that so far? All right. So let's talk about the data models. I said sorry, there was a question? No, okay. So I said the data models were the basic infrastructure, the underlying infrastructure that is used for building programmability of the platform and to have very effective network automation. So right now we have a pretty, on Cisco devices, we have a pretty strong support for data models, or we have, I should say, a heavy investment to support data models. The platform or the operating system that is ahead in the implementation is the iOS XR platform. We should be fairly, we have already some support for sure on Nexus devices, and we have pretty soon, I think we have in beta support on iOS XE. But I think in 16.1, I think, I'm not very familiar with the releases on iOS XE. We're also going to introduce support for data models. So in this presentation, I'm going to talk specific about the models on iOS XR, because again, the platform that has the widest support for data models today. But just taking into account that what I'm describing here with respect to data models, you should be able to apply it to some extent on Nexus, and pretty soon you're going to be able to apply it also to iOS XE platforms. So, as I described before, data models define a tree structure that contain a specification of the configuration, operational state, and commands that are supported by the device. Okay. In iOS XR, we have around 250 data models that we support. Those data models are mostly what we call native data models, meaning data models that are specific to iOS XR platforms. There's a growing number of open config models. Open config models are third-party models that are vendor neutral. Okay. It seems that we got the recording going now. Okay. With respect to what kind of things you can configure on the box or what statistics you can can pretty much get everything the box can do using the native models. When it comes to open config, because they try to be vendor neutral, by definition, they can only provide a subset of the functionality that the box can provide. So it's basically a trade-off between getting all the details of the platform using the native models, or getting partial details and partial functionality from the box using open config or vendor neutral, but you get the benefits of being vendor neutral. Okay.
So, question?
Yeah.
So in this XR, what is the coverage of the data model? Is it covering maybe 80% of XR configuration even with the native model, or what is the coverage?
Right now, it's pretty much 100%. Sometimes we find corner cases of things that have fell through the cracks, but pretty much any area where we find that, it gets treated as a defect.
Okay. So even with the operational mode or just with the configuration mode?
Both configuration and operational. The only area where we know we still have a few gaps, but we're closing it actively, is in commands, in RPCs. So basically on exec commands, what kind of commands you can execute in the box. So we've done like there's some SNMP test commands that you can run from the exec. There's syslogs that you can generate from the exec. So we now have an RPC for that. Doing a ping and a trace, we have now an RPC for that, or a model for that. So there's a handful of exec commands that we still haven't implemented, but we have a roadmap to close that gap. I would say probably it's going to take us another 12 months maybe to do that.
Okay, and is it supported by TAC?
Supported by what?
TAC?
Oh, big time. We started introducing models since 5.3.0. So that's what, at least 2 years ago or 2.5 years ago? Yeah, big time, yes. All of the stuff all of the stuff, actually, let me go back to that diagram just to, for those of you who are curious, all the stuff that I'm showing here is available with the only exception of RESTConf. We have an implementation of RESTConf, but we haven't released it due to less than expected customer interest, I should say. So we did the development work, and because we haven't had really a lot of customers yelling and screaming for the functionality, we didn't release it. But other than that, everything that I'm describing here is available today on iOS XR. Some components of this are supported also on Nexus and in iOS XE, but the widest support for this by far is on iOS XR.
Okay, thanks.
Okay. All right. So I described before that these data models have a formal specification that makes them computer friendly. The language in which those data models are, Cisco creates those data models for native data models, and a third-party organization, OpenConfig, creates the data models for their own ecosystem. Those data models are specified in a language that is called Yang. It's an RFC. And it's a language that it looks C-like. I have one slide just so people can see the syntax really quick. We don't need to drill too much on the details of Yang as a language, but I guess a key point that I wanted to drive here is, since the data model defines a tree, what are the key building blocks that are used to build this tree? How is this tree put together? And Yang defines basically four main abstractions it's kind of the Lego that you use to build that data model. When I say you will not build your own data models. We use to build the data models, okay? One of them is a leaf that is basically a node in the tree, an ending node, doesn't have any child, any children, that's going to have a type and a value, okay? So what's an example of a leaf? Let's say, for instance, the configuration of an interface. In the configuration of the interface, you're going to have an MTU, right? That MTU will be a leaf. What will be the type? Is going to be an integer, right? And in addition, you may want to specify not only that an MTU is an integer, but you may want to define that it has to be a positive integer. Not only a positive integer, that it has to be within a certain range, right? That you cannot use an MTU of 10 million, for instance, right? That would be invalid as a configuration. So the leaf has a type, a value, right? And it may have some constraints that apply to that node. You can have a leaf list that is basically a set of leaves in the mathematical sense, okay? So you can have multiple instances of a leaf. They will have the same type but different values, and one of the characteristics of the leaf list is that values don't get repeated within the leaf list. So again, it's a set in the mathematical sense. You don't have elements repeated within the set. The third next abstraction is the concept of a container. Don't get confused with virtualization. People talk a lot about containers. In data models and in Yang, container means something different. Container means basically it's an abstraction that groups other nodes. Okay? And the last item is a list. And the list typically behaves kind of a record in a database, if you want to draw an analogy. Basically, a list is typically multiple leaves or multiple nodes that are associated with a key, and the key needs to be unique. So what would be an example, if we go back to the interface example, right? I said MTU could be a leaf, a list could be the configuration of all your interfaces. You will have a list of interfaces because your device is going to have more than one interface. And the key is the element that identifies an interface, makes it unique. In the case of interfaces, it will be the interface name. The interface name identifies the unique identifier of a particular interface. Yang defines at least a couple of interesting functionality. One of them is the concept of augmentation. So if you define a model can be extended through a process that is called augmentation. And the second one is a deviation. If you define a model and the device, for some reason, is not able to support parts of that model, the device can document a deviation. So it's basically a disclaimer from the device saying these parts of the model I'm not able to support. So this is how a very simple YAML model looks. I'm shortening the example because it wouldn't fit on a single slide, but I'm just showing a potential model for configuring community sets on a router. Community sets are used in routing policies for BGP. It's very common to have communities, and you define these community sets, and they are referenced within policies. Okay. So you see on the left-hand side an example where we see a container. Oh, I have the pointer here. Let me use the pointer. That might help. Can you guys see the pointer?
Yeah. Yes.
Okay, so we have a container that is called community sets. Remember, the container is nothing but a grouping abstraction, okay? There's a description, basically it's an annotation to describe what this container is about. And under the container, we have a list of individual elements that are called community set. The key, basically the value that identifies a community set is called a community set name. And if we look here, we see that the community set name is basically a leaf that is defined as a string. Okay, so it's some kind of string that defines the community set. The list also has another node that is actually a live list. Remember, a live list behaves as a set. In this case, it's a live list of strings, but these strings have a constraint. They have to be basically, this is a regular expression and define basically a number, colon, another number, okay? If we look at the right-hand side, you see a CLI representation. This is not an exactly valid XR CLI, but it's XR-like, very close to actual CLI on iOS XR, that would be compliant with this definition. We see that all the configuration is grouped under community sets, which is the container, right? The container that was defined here. We see that there's a list of elements that are called community set. In this case, we have two community sets, okay? And we see the key. The key is the community set name. In this case, CSET1 and CSET10, okay? Within each community set, we have a live list that is a set of communities, and we have here the communities, and we see that the communities match that regular expression, right? We have one number, colon, another number, okay? So with the proper tooling, I will be able to verify whether this CLI is a correct configuration or not. I could verify, is this CLI compliant with this model or not? And that's, to a big extent, that's what you're trying to do with data models, to have kind of a generic definition and then having instantiations of those definitions and be able to validate those instantiations against the definition. So for those of you who have programming experience, and more particular, those who have experience with object-oriented programming, it's similar to the concept of a class definition and an object, right? The class definition is your generic definition. Object is an instantiation of it, okay? And we're going to see that that analogy is going to be useful down the road. So this same data or this same configuration that I show here via CLI, we see that it can also be represented in XML. So this should drive the point that the data model is not really, it's a generic definition of a hierarchy, in this case of configuration of community sets, that is really agnostic from the way the data is encoded. So in this case, we're using XML, and we basically have exactly the same configuration. We have community sets that are grouping two instances of community set. We see the name, and we see the three community members, okay? We could do a similar exercise, for instance, with JSON. It's another way, JSON is another way to encode data, and we could do the same exercise. We could even do the same exercise, for instance, with YAML, for those of you who are familiar with YAML, or you could do the same exercise, for instance, with Google Protocol buffers. So those are different ways to encode the data, and you could still use tools to validate whether the structure and the hierarchy of the data is correct with respect to the definition of the model. Okay. Any questions on that? Okay. So, so I just gave you a very quick crash course on data models. And when people are first introduced to the idea of data models, you're saying, okay, makes sense, it's a tree, and the tree defines configuration, or it may define statistics and all that, okay. And it's YANG, and you can maybe browse the YANG file, and you can, you know, if it is a small model, you can make sense of the YANG model. But then you wonder, okay, how do I make use of this? How can I really start reaping the benefits out of this and start doing automation on the network? So this is like a big gap that people have from really understanding what data models are and really being able to use them. So that gap is what we're trying to bridge with a model-driven APIs. So our hope is that, for instance, someone that has programming experience should be able to start making use of these models, be able to configure a device, for instance, and not have to learn. They don't have to go and learn, you know, or read tens of YANG specifications and specific YANG models. They don't need to go and read RFCs, for netconf, for RESTconf. We want to be able to abstract that as much as possible to really make it simple to interact with the device and automate the network. So we do this with model-driven APIs, and what we do is we created a tool that takes a YANG model that, again, defines a hierarchy, and we create a library of classes in different languages that completely mirror the structure of that data model. So to the developer, you can go with, okay, this is your library that you use. Let's take an example. We're going to configure BGP on the box, right? So we say these are the classes that you use to configure BGP on the box, or these are the classes that you use to configure interfaces on the device. And the structure of those classes are going to mirror exactly the structure of the YANG data model. To begin with, that's a big win for a developer because that person is not going to have to go and read YANG, learn netconf. It's speaking the language of a developer. I can understand classes in Python. I can go and figure it out and make sense of that stuff. I don't need to go and learn all those RFCs to really understand what I can do on the box. This is an example. If we go back. Or if we compare this to the slide that I showed before, the same CLI configuration on the right, but now being represented actually as Python code, okay? And we see here that I'm able, to represent the same configuration in Python code. And this Python code, it may take a little bit more time for you to figure it out, but it's basically the exact hierarchy representation that we saw before in terms of XML, that we see on the right-hand side in terms of CLI. But in this case, the hierarchy is built out of Python objects. So we have a top object of community sets, okay, and we have two instances of community set. Here we specify the name, and we create a list of the three communities for the first set and the three communities for the second set. Okay. So, how are these APIs generated? These APIs are generated with a tool that we created and we open source that is called YANG Development Kit. Okay, YANG Development Kit really has several components. One key component is the generator that we call YDK Gen, and what this software piece does, it takes as input any YANG file, and it generates those libraries in different languages. So far, we've implemented the generation in Python and in C++. Today, we're kind of assuming Python, but if anybody's interested in C++, we also have C++, and the idea is to support more languages down the road, okay? So these bindings that we generate, or these libraries that we generate, we store them in separate repositories. All the YDK software resides, it's open source, and all of it exists on GitHub. So the Python bindings are stored under the YDK-Py repo. The C++ are stored under YDK-C. What kind of data models we use as input? We use IDF models, we use XR native models, and we use OpenConfig. Okay. As Nexus and iOS XE start to support more models and native models, we'll start creating also in these repos, you're gonna find support for XE and Nexus. Excuse me, from a user perspective, it would be less likely that you would use the generator. The generator is basically used to generate APIs from source YAML files. Some people may want to do that, but for most people, all you want to do is basically use the libraries and the bindings that we already generated. One of the key pieces of YDK is that it automatically gives you code, or it doesn't just give you code, it actually completely automates data validation. Remember, when I was talking about the data model, a key reason or a key value of the data model is that the data model is a generic definition, and I said you should be able to put, in the case of the configuration of community sets, I could put any configuration through a tool, and the tool should be able to tell me yes or no, is this configuration compliant with that model or not? And if it is not compliant, it should be able to tell me where is it that is not compliant? Where is it that you made the configuration change? And that's exactly what we do on YDK. Because the APIs are generated from the data models, and the data models not only define the hierarchy of the data, but it also defines the data type, valid values. We do all kinds of checks automatically for you. So if you write a client application to automate something on the device using YDK, we will check, for instance, that your client application doesn't try to write information on the device that is read-only. It doesn't make sense. What would be an example of that? For instance, you trying to write counters or statistics to the box. You cannot tell the box how many packets have gone through an interface. You can only read that. That's operational state that you can read. It's not information that you can write, okay? So if you make the mistake, for instance, on an application that you're trying to write statistics to a box, your script will throw an exception. It will tell you locally, hey, you got a mistake here on your script. You shouldn't be trying to write stuff to the box that the box cannot or doesn't allow you to write. The APIs also check your types. So if you, for instance, if an MTU, we said the model specifies that it's an integer and it has to be a positive integer and it has to be within a range. If in your script you made a mistake and, for instance, you specify MTU and you assign a string to an MTU, your script will throw an exception and say, hey, you're making a mistake on how you configure an MTU. Okay? Or if you maybe use an integer but you use a negative value obviously is not valid as an MTU. Again, your script will throw an exception and say, hey, you're violating the model, you're not sending a valid MTU. We also do semantic checks. So I said before that if you have a list within the model, the list typically has a key, and the key has to be unique. So in the example that I gave earlier of a list, being, for instance, the configuration of your interfaces, and the interface being the name, being the key of that list. If you try to configure two separate interfaces with the same interface name, it will throw an exception and say, hey, interface names have to be unique. You cannot configure two interfaces with the same name. So we do all kinds of checks. We would also do, your script will also automatically do checks for deviations. Remember that I specified before, deviation is a mechanism for the device to declare that there are some pieces of the model that it cannot support, okay? Because maybe it's a platform-specific limitation, right? That particular platform cannot support a particular part of the model. The script would automatically detect that, hey, I'm talking to a box that is already telling me that it doesn't support certain functionality. If your script is trying to talk to that box, the script will locally do the validation and will throw an exception saying, hey, you're trying to set this value in a box that already told you that doesn't support that. So this is a big, huge reason behind using it's not the only value, but this is one of the key benefits of using these APIs. If you take a look at the details of the APIs, if you start browsing the packages and how things are structured, one of the things that you're going to find is that the APIs, the libraries, have three main abstractions: models, services, and providers. Models is kind of what I've been saying so far. It's basically the classes that we auto-generate from the YANG model, okay? Services and providers are handwritten. Those are not auto-generated from YANG models. And services is basically a library of operations of services that you can perform on objects that you created from the models. And the providers is kind of the lower level implementation of the services. Excuse me. So let me give you an example, for instance, of a service. A service that we defined was a CRUD service, a create, read, update, and delete service. So you can create an object, for instance, for configuration of BGP or for configuration of interfaces. You populate that object with whatever parameters you want to configure. Then you make use of the CRUD service to tell the CRUD service, I want to create this configuration on this device. CRUD needs to have an implementation, ultimately needs to talk to the device. So CRUD typically use a provider, which is netconf. Netconf is the protocol that ultimately will talk to the box. Okay? The service and the providers are in charge of taking that Python object of configuration that you created, whether it was for BGP or for interfaces. They will validate the data. In this case, because you're using netconf, they will convert it to XML. They will create the proper netconf message to send to the router. In this case, we're trying to create configuration IOSXR. So that CRUD service will be in charge of validating the data, convert it to XML, create a netconf message, send the edit config, wait for an OK from the box, send a commit message, and wait for an OK. Okay, so all that stuff is done automatically, and it's kind of abstracted away from the developer. Okay.
Question?
Yes.
So when you're implementing that for iOS devices which do not have the commit concept, right? So will it be coming on the devices which start supporting commit, or
no? In iOS is being added the capability in iOS XE, the commit capability is being added.
Okay.
So
what about Nexus?
When we support netconf YANG, you will be able to do commit.
And is it the same thing with Nexus as well?
The same with what?
The same thing with Nexus as well, the Nexus OS.
With Nexus, I'm less familiar, to be honest with, but in this case, the CRUD service should be smart enough, because when we specify, for instance, in the CRUD service that netconf is going to be the provider, when a netconf session is open, the first thing that you get from the device is the capabilities, and the capabilities of the device will tell you whether the box uses candidate configuration or whether it requires commit or not. So based on that, the service could do the right thing when talking to a device. We'll know whether it needs to send a commit message or not. Okay? Good question. Okay. When we look at the packaging, I said we generate today APIs in Python and C++, and this is the details of the packaging for Python. It's kind of similar packaging that we're also using for C++. So we have what we call, when we released almost a year ago, 11 months ago, we made YDK public. We had everything in a single Python package, and we quickly realized that we needed to make it more modular. So what we did is the definition of services and providers, which is the handwritten code, resides in a package that we call the core package. Okay. In addition to that core package, you have specific bundles, what we call model bundles, for each of the model ecosystem, which is the bundles on the left. And this is the stuff that is auto-generated. So, excuse me, you'll see an iOS XR bundle that has all the native XR models. You'll have an open config and you'll have IETF. As soon as Nexus and XC start to support their own native models, we will create additional bundles for them, okay?
And does it change with the change in the release? So let's say I'm on 5.1, now I go to 6.0, which has more capabilities. So where do I get the updated
Yeah, that's a good question. So actually, each of these are separate Python packages, but actually the model bundles are kind of sub packages of the core. So you can even, or we can define dependencies between these. And the key benefit of making this modular is that it allows you to only install the models that you care. So maybe you're managing XR boxes and you're not really interested about OpenConfig, so you don't need to install that package. Or you're not interested in IPF, you install it, or vice versa. You're only interested in OpenConfig, you only install OpenConfig. Or I want to upgrade the native models, but I don't need to update the OpenConfig or the IETF. You can install and you can upgrade each of these individually, and the packaging takes care of the dependencies between the model bundles and the core package. Okay? Sorry. So here's an example, maybe a more complete example than what I showed before. Before I kind of showed, okay, the same data that we had in CLI, how it could be represented in Python. This is actually a complete script that can run to completion and does something. Not super useful, but it does something. So basically, it connects to a box that supports, an XR box that supports open config models, and it's going to enable BGP with Autonomous System 65,000. And then it closes the session, okay? If after this you went to the router and you did a show run, you will see router BGP 65,000 being enabled, and that's it. You wouldn't see any address families under BGP, or you would not see any enabled configuration, but you will see that BGP was enabled, okay? So you see here in the top part, the packages that we're importing in this particular script. So we're going to make use of the CRUD service. We're going to make use of netconf as a provider, and we're going to be using the OpenConfig BGP model. Sorry. So I'm going to focus on these three lines. What is it that we're doing in these three lines? We're creating an empty BGP configuration object. Okay. So here I instantiate that object. After I create that object, I go under BGP global config AS, and I set that value to 65,000, and then I create that object, that configuration object that I instantiated here, or that I populated here. I'm specifying here that object I want to create using the provider that I defined before. The provider that I defined before is basically a netconf provider that I said, I'm trying to connect to this box on this port with these credentials, okay? So what's happening in this line? How did we know that BGP global config AS is where we needed to set the autonomous system to 65,000? When we look at the tree structure, remember, models are a tree. When we look at the tree structure of the model, we see that the model has a root that is BGP. Under BGP, it has global. On the global, it has config. Under the config, it has AS. So that path in the hierarchy is exactly the same path that you have here. The names are also the same. The only reason why we have underscore here after global and after AS is because those are reserved words in Python, okay? But other than that, they will look exactly the same. So again, if we go back to what I said before, for a developer to be able to start doing automation of configuration of operational state, it's much simpler to understand this hierarchy and to understand that it has a hierarchy of objects that follows that hierarchy and set the value and have the automatic validation of that. That person didn't have to learn Yang. It didn't have to read and examine the Yang model for OpenConfig BGP. It didn't have to, if you look at this code, even though we're using netconf, in this code, and netconf uses XML, we're not even importing an XML library. There's no XML that I need to manipulate here. My only reference to netconf is basically saying that I want to connect to this box using netconf. I'm not having to specify or build the netconf messages myself. All that stuff is completely abstracted away from me. The only thing I need to learn is what is the hierarchy, what that hierarchy, set the value, and then invoke that I want to create that object on that device. Okay? So it's significantly simpler than trying to do this level of automation without these APIs. Some of you that may have some experience with netconf and maybe some experience with Python, you may be familiar that Python has a library called NC-Client that allows you to build scripts to automate with netconf. Well, if you try to do that, if you try to use that on a library, you still have to worry about manipulating the XML, so you have to somehow write code to handle XML yourself. You need to decide what are the RPCs or the netconf messages that you want to use. You need to kind of understand the logic of how to use netconf. There's a lot of stuff to learn there. Not only that, because you're using NC-Client. NC-Client is not aware of data models, is not aware of YAML. So you can build configurations in XML that are valid XML, but they are invalid configurations because they don't really correspond to configurations that the router is willing to take. Okay, so this really automates and simplifies a lot your automation of configuration.
Question?
Yeah. So
to go back to the previous slide, so there's a question mark after some node. Does it mean they're a list or?
What's that again?
Where you have the Python code, if you go to the slide.
This one?
Yeah. So on to the right, there's a question mark after some nodes, and there's an exclamation mark after BGP.
Ah, okay. You can kind of disregard that. On the right-hand side, the output of that hierarchy is with a tool that is called PYAN. It's an open source tool that also people from Cisco, actually from TLF, created. It allows you to visualize very simple from the command line on a computer. If you have the YAML file, it allows you to visualize very nicely the model in this tree representation. And the exclamation and the question marks and the brackets have specific meanings. They tell you if something is mandatory, if it is optional, if it is a list or a key. That's not as important for what we want to show here. The key point is understanding that if you understand the hierarchy of the model, or if you can understand the hierarchy of the model, you will be able to use the APIs without necessarily having to learn anything about YAML. Okay.
And the API I will get from the module and packages you have said, right? Will it also have these YAML files as well?
I didn't quite understand the question. Can you repeat it?
So the APIs that you have told, right, which are generated by the API generator, that we can download from the resource that you will provide, right?
Yeah. So the models are public information. Our models, we also post them on GitHub. The ITF models are also posted on GitHub. The OpenConfig models are also posted on GitHub. In addition, you can programmatically ask the device to give you the models. So there's many options to get the models.
Okay, so that means it will give me that YAML file which I can then technically use the YDK generator and get the API.
Yes. Okay. Yes. But again, if you're trying to use XR, or you try to use ITF, or you try to use OpenConfig, we already generated the APIs for you, so you didn't have to worry about finding those YAML files to generate the APIs. We already generated those in Python and C++. But if you maybe want to do it, I don't know, you want to create your own models, or you want to use models from another vendor, yes, then you will need to do that.
Okay. And one more question: is there a versioning of when you generate these APIs? Is there a version number which corresponds to a specific iOS number? Okay.
Yes, I can show I'm hoping to be able to make a demo at the end, and I'll show that. And if you don't see it, by all means, remind me, and I can show you the versioning. Okay.
Okay. And they're all backward compatible, right? If I use a newer version of API, I can still use the old XR version which supports the same thing.
So Yang has rules of backward compatibility, okay? In the industry, there's a little bit of debate on whether those are the right rules or the most realistic, I should say, whether those are the most realistic backward compatibility rules. Let me say that the APIs that are generated they are as backward compatible as the models, right? So if the model breaks backward compatibility, of course the API is gonna break backward compatibility. I think probably what's going to happen in the industry is that the initial goal of Yang of being completely backward compatible over time is too restrictive, and because we ultimately what you're trying to achieve here is being more kind of software driven, right? It's adopt, I would say, software practices. In software practices, typically, for instance, you do semantic versioning in which you are backward compatible within a window of time, and maybe in some major releases, you're willing to break backward compatibility for hopefully, good reasons, right? So that's probably how I see the backward compatibility going forward.
This is a topic that has spawned lots and lots of discussion in the IETF and in other bodies on how to deal with this. And it's almost worthy of a whole nother session if you wanted to get into that. But for now, let's just move on with the data models as they are. And you can pull up some of the IETF specs on the Yang data model. And if you want, you can join the discussion groups in the IETF, and you can participate in all of the, shall I say, back and forth on this topic. Go ahead.
Okay. So this is kind of the evolution that the project has had. Again, the project from day one has been open source. We went public in mid-March. Actually, I didn't know that. In 2 weeks is our first birthday. We need to get a YDK cake. I'm gonna get it. So we went, the first public release was 0.30 in March, and we have a pretty good cadence. This is, again, we developed it in a completely open source fashion. There's no internal Cisco's YDK and external Cisco's YDK. In the external repo on GitHub is what we use for all our development. We have a pretty good cadence of every 4 to 6 weeks. We have an additional release. Everything again goes on GitHub, and this gives you some visibility on all the evolution. Most recently, in January, we released support for RESTconf and also support for Open Daylight. So you can use our API to talk to a device that is behind Open Daylight. Open Daylight is another open source controller project that also supports Yang models. So you can use our APIs to configure a device or read information from the device going through Open Daylight. If you want to see all the details of the releases, you see the details here on the bottom. These release numbers for the person that asked me before the versioning. This is the versioning of the core package. Okay, in 0.50 was the first release in which we went to the modular packaging. So before release 0.50, everything was monolithic. It was a single package. From 0.0 and on, we've had the modular packaging, and these versions are the ones for the core package. Okay, the next release we expect it to be 0.60. And hopefully, with good luck, I think we're measuring in weeks, less than a month, if everything goes well. All right. So, excuse me. So, what are some of the future work items? We have multiple areas where we want to enhance. One of them is to have built-in support for Google RPCs. If you remember from one of my initial slides where I said we have multiple protocols to talk to the device and interact with the data models. I showed netconf, resconf, and Google RPCs. We already have support in the libraries in YDK for netconf and resconf, but we want to add support for Google RPCs. We also want to have, in the same way that we did extensions, so you can talk to devices that are controlled by OpenData, we also want to enable users to use the APIs to go through Cisco's NSO orchestrator that is built by TLF. In addition, we want to also bring additional languages. We don't know yet what will be the next language. I'm hoping it could be Go. We have some people showing interest for Java too. We still haven't decided, okay? So how can you use it? The ideal is that you go on GitHub, you check out the repos, and you install it on whatever box you have. So basically on a device that supports Python, whether it's Apple, Linux, or Windows, you can install YDK. All you need to do is install Python and install YDK. You will install the core package and the bundles for the models that you're interested in, XR, OpenConfig, ITF, or Tomorrow, XC, or Nexus. The other option is to use one of our sandboxes. So if you're not familiar with Python, maybe you have a Windows laptop and you're not too familiar with Python and all that, you don't want to work through all these setups. Another option is to use a sandbox. We have two sandboxes, one of them using Vagrant. So Vagrant is an open source tool that facilitates the creation of development environments in a very simple fashion. So if you install Vagrant and VirtualBox on your laptop, you can create a Linux, or we provide a sandbox in a Linux machine that already has YDK pre-installed and also has hundreds of sample apps. Very simple sample apps, but you get lots of them. You get over, I think right now it's probably like close to 560 sample apps, okay? The third resource that became available, and this one became available a couple of weeks ago, is that you can run YDK on the cloud. So how many people here have heard or have used dcloud? Just make some noise because I cannot see your video.
There's probably about eight.
Okay, that's good.
So shame on the rest of you for not knowing about dcloud, because it's one of the best kept secrets Cisco has. Look into it, okay?
That's exactly what I was going to say. It's free compute to do all kinds of learning, all kinds of labs. This is like a candy store, okay? So you go to dcloud, D stands for demo, democloud.cisco.com. You log in. You have to have a cisco.com user ID, of course. You log in, and if you're registered as a customer, it may not work if you just have like if you just created a Cisco.com account with a Gmail account or something, it may not work for you. But if you're registered as a customer, basically if you have Cisco devices and you have some kind of support contract, you're going to be registered as a customer. You are able to just search in the catalog for Young Development Kit. That Young Development Kit sandbox gives you a Linux box. It basically creates a virtual lab for you that has a Linux box that already has YDK installed, and it has two iOS XR routers connected back to back. Okay? And it has the Linux box that has YDK installed also has hundreds of sample apps installed, so you can start running those scripts against the routers.
A little comment here. How many people in this room are working for a company that's doing networking? Okay, so you probably have a contract, and all that's probably necessary is to get whoever is negotiating and working with Cisco to add you as a member of your company.
Exactly, yeah.
And then now you have access to dcloud. Okay, yeah, you may not be doing active, downloading images and upgrading boxes, but if you can get them to add you to that list of individuals for your company, then you can access dCloud, and it's a great learning thing. And the way you justify it to your manager is just that. This is a learning experience where I can spool up a lab and experiment and learn new techniques and new things, and this is what I need to, become a better employee and a better, network administrator or whatever it happens to be. So there's good justification for them to do that. So keep that in mind.
Okay. So some of the external resources that you have available, I mentioned before that we have a lot of repos actually on GitHub. So YDK-Py is the repo for the Python APIs. We have YDK-Py samples, that's the repo that has over 500 sample scripts. We have the YDK C++, which is called YDK-CPP repo. It's kind of an alpha because we introduced it recently, but it's very usable. So we're still doing a fair amount of testing, but so far it's shaping up pretty well. We have a C++ sample apps repo that right now it's kind of empty. I have to start putting the examples there, but I wanted to include the URL anyway because in the next following weeks I'll be porting the sample apps in Python, porting them to C++, so you're gonna find them there. This is the link to the generator. Again, the generator is something that most likely you would not use yourself, or most people would not use, but if you're interested, that's where the generator resides. The documentation is online. This is documentation for YDK-Py, documentation for YDK C++, and I'm going to flash those websites pretty soon so you get an idea of how the documentation looks.
Do they have to have Git installed on their machine to pull those down, or does that just make it easier?
No, you can actually, technically you don't even need to have a Git, just to download it, you don't even have to have a GitHub user ID. I think you can just, from the internet, it's public information because it's open source, you can get a zip file basically with the whole repo. It's good as a starting point. What I would suggest if you really want to get a little bit more serious about this or network programmability and software in general, it's good for people to kind of become familiar with Git and kind of try to install Git on their laptop and try to use the workflow for software. I know it's a little bit painful to start with, but the good news is that there are a lot of online resources. GitHub actually has like an online sandbox where you can learn the basic Git commands. Something like that it probably takes you like 15-20 minutes to go through that training, and believe me, when I said at the very beginning that if you're kind of new in your networking career, I said that the changes in networking are so dramatic that are really leveling the playing field. This is kind of what I mean, right? Software and being able to automate is becoming more important. Being early in your career it's not a handicap next to the guy that maybe has done it for 15 or 20 years. That person may have a lot of networking experience, but may struggle with Git as much as you would struggle. So highly recommend that people go through the effort of doing it in the right way.
How many people in here have Git installed on their laptop? Okay, those of you who don't, if you've got Mac or if you got Windows, you can get, pardon the pun, Git installed onto your laptop, okay? Then once that's installed, the command line under your command line would be git clone and one of these links. And what it would do, well, it would pull down, for example, YDK-PY, and that entire repository would come down and be put onto your laptop under probably the YDK-Py directory, or you could specify which directory you want to put it under, and now you have everything that he's talking about here. The other way is you go up to those links and you will see the repositories, but now you're having to individually file, copy what you want. The easiest thing to do is put Git on your laptop and at least learn git clone as the command to pull it down. And of course, He's busy writing new code all the time, so the other thing you want to learn to do is get pull, and that will pull the latest versions that he's written to your laptop. Sorry for the interruption. I just wanted
That's fine. So a couple of things I wanted to mention. Each of these repos has a README file that explains also how to go about the basic installation, and I also put a summary of those instructions as backup in this presentation. So I'll send you both the presentation later, and if people are interested, remember you have the option of installing it yourself or using some of the sandboxes. If you maybe want to start simple, probably the sandboxes are the simplest. If you want to install it yourself, you can find the instructions in the README files of the repos or also in the backup of this presentation. Okay. So these are other useful resources. We actually have a portal in DevNet. DevNet is a website that Cisco has for technologies that are relevant for software developers and for network automation. So in that family of websites, which is DevNet, we have a page for YDK, and under that repo, actually I can show that really quick. It's a portal where you find all the links and resources that we just discussed in here.
How many people in here are members of the Cisco DevNet?
You can browse it even without logging in. You see here that I'm not logged in, and you can browse. But
there's also the DevNet. What is it? DevNet Learning Zone.
Oh, right? It has all kinds of online. It has all kinds of labs also. Yes.
There you go. You need to get hooked up with that as part of your learning process.
Okay, so this site, it basically gives you like a one-click download. It has some documents, pointers to the repositories. So this could be a very simple way to have kind of all the links in a single place. These are pointers to the sandboxes, and also we have a community. So because this is open source, the support happens in the open. So we have a community, a public community. That's where you ask questions. Anybody, all the developers participate in the community. Sometimes they respond. Sometimes we have other users and other customers also replying. So it's open to everybody to participate. The only thing that you need to do is just have a Cisco.com user ID. Okay. This is the pointer. I have a slightly longer version of this presentation that I delivered at NANOG. Bo was there in that presentation. It's an hour and a half. So if you want to look at it in YouTube, if you're a little bit more Python savvy and you want to know a little bit more of how the CRUD service works and how the different providers work, I gave a little bit more detail in that presentation. So you can go there, kind of watch. A lot of the content is going to be similar to what I'm describing here, but there's some additional material that you're going to find there. I also presented this at LinuxCon in the summer, so this is another link to that. You may find that useful. Oh, those are external resources that I was not supposed to share. Okay. Okay. You didn't see that, by the way. Okay. Any questions before we jump on a quick demo?
One question. So the YDK itself is just that one of those APIs, or is it the combination of API and the generator, the YDK generator?
The whole project as a umbrella includes everything, right? But at the end of the day, it's modular, right? If you go and use YDK-Py, YDK-Py doesn't include the generator because most customers just want to use the API. It will be extra baggage there to have the generator, okay? And for most people that are kind of generating APIs, they don't need to carry all the baggage or whatever it is that we're generating for YDK-Py. So we have it very modular. The code base is very modular, right?
Okay. And is the intention of giving that generator is so that we can generate these APIs for other vendors as well? Was that the intention?
our intention is not to generate ourselves, but that will not stop other people from generating them. Given that this is open source, something that we may be willing to do, and we still haven't implemented this, but probably something that we're willing to do is the generator takes what we call a profile definition to create a model bundle, okay? What we may be willing to do is to take that profile definition from other people that maybe have used a generator to generate from vendor A, B, and C, and if they want to contribute back saying, hey, this is a profile that can be used to generate APIs for this vendor and this release, we may be willing to take those profile definitions, but it wouldn't really be very practical for us to generate try to generate APIs for other vendors for many reasons. Putting business considerations aside, you know, there's a lot of effort in generating the APIs, making sure that the models are clean, that there are no errors in the generation. We need to generate the documentation. We need to host the documentation. It wouldn't make sense for us to be in the business of dealing with errors on models of other vendors or trying to host documentation for other vendors.
The real solution to that is convince that vendor to support the open config model, and you're done.
Exactly, yes. So, and that's a very good question, or a very good comment, I should say. The open config ecosystem is getting a fair amount of traction, and it's getting a fair amount of mindshare, basically because they're really delivering, they're moving fast, and they're really iterating and making progress. So if you really have the open config model bundle, that already kind of gives you a cross-vendor solution. But you know, still some people may want to be able to use it with other vendors, and that is possible. I've done it myself, and I know of at least one customer that has done it also. But I can tell you that in both cases, the generation required manual manipulation to make things work, because this other vendor, for instance, has violations of basically their models are broken in some pieces. They're not fully compliant with the specifications of Yang, Yang in general. So it requires manual manipulation, and we don't want to be in the business of trying to fix all the stuff. We're busy enough trying to fix our stuff. Okay. Any other questions?
Do you have any production rollout of this?
Any what again?
Has anyone deployed it in production? Yes.
That's a good question. What we kind of seen is that the industry is still a little bit in the early stages of model adoption, data model adoption, because when you really see even devices, not many devices in the industry are fully data model. Like XR is way ahead. But even for Cisco, some of our other operating systems are a little bit behind. So I think the adoption curve is still in the early stages. But having said that, we have at least two tier 1 service providers in the U.S. that have expressed clear intention of using this for automation. Okay. Also, we have one of the largest analytics and machine learning projects that we have right now. It hasn't been released, so I cannot talk too much about the project, but one of the largest projects that we have for network automation and machine learning leverages this API. So basically, we're eating our own dog food. This is, even though it's treated as an open source project, but it is an open source project, it's not a toy tool. For us, it's a production API, and we use it internally. So if we do bad things with the models, if we do bad things with the APIs, we pay the price in our development cycle. So we're trying to make it work and keep it in good shape. Any other questions? Okay, so let's try to jump to the live demo. So in this live demo, I'm going to be using excuse me, the dCloud setup. As I mentioned before, when you instantiate a sandbox for YDK on dCloud, you get 3 devices. You get a Linux box that is called a controller. It's nothing but just a Linux box with YDK installed. I'm calling it logically a controller. And two routers, two XR routers called R1 and R2 that are connected back to back. Those routers already have the interface pre-configured, and they already have ISIS as routing protocol pre-configured. All these three devices talk to each other through a management network, an out-of-band management network, and those are the addresses of the devices, okay? So let me go to the setup. So this is the sandbox on vCloud, and I already instantiated. So I get basically on the browser, I can connect to the individual consoles of the individual devices. Okay. So let me. This is my controller. I have to connect to the router. Let me bring the console of a router too. So let me connect to R1. Okay. Excuse me, let me make the font a little bit larger. So appearance, change 22. Okay, apply. All right. So just to, we don't need to look at all the details of the configuration, but just I remember I said that R1 and R2 were pre-configured with all the addressing, management ports. We have even routing. So just to show you really quick, there are routes that are being learned. If we look at the routing configuration, there's some configuration that already exists there, right? But again, we're trying to do things programmatically, not to do CLI. So I just wanted to show that so you could see that the box exists and is pre-configured. Okay. So when you look at this controller, the Linux box that has YDK pre-installed, let me first show you that it's installed, and that goes. Someone asked me about that before. So okay. So you see here that you have 4 different Python packages. This is the core package. So the sandbox is using is slightly behind one release. With the latest release was 0.5.3. It's running 0.5.2, and we have the 3 model bundles. Okay, so with this installation, I can use XR native models. I can use IETF, and I can use OpenConfig. For XR, you see that the versioning is independent, and you see that for XR, we use the same versioning of the operating system. So basically, these are the data models as they are supported in iOS XR 6.1.2, okay? So what else is here? I put excuse me. I put a bunch of YAN files, not because I want you to look at. Sorry, did I show the right thing? I wanted to show this. Yeah, not because I wanted to look at YAN files necessarily, but remember with PYAN you can see the models in 3 formats. So it may be useful for you to just experiment and browse those using PYAN. But the directory here that is more interesting is this, YDK-Py samples. Remember that I mentioned that we have this repo. Let me go, oh sorry, it's in the browser actually, yes. Yes, YDK. We have this repo, this is the one that has over 500 examples, okay? So this repo already comes pre-installed in the sandbox, okay? And what we're gonna do is we're gonna run some of those sample apps. So I'm gonna browse some of them, just let you look at the Python really quick, and then we're gonna see what they're doing, okay? So I'm gonna go and look for apps, sample apps that are using the CRUD service. Remember, the CRUD service is a create, read, update, delete abstraction on top of netconf, so you can manipulate the devices without having to learn netconf, okay? Models. Let's say I want to use Cisco IOSXR model. So these are all the models for which we have sample applications. Let me see which one I want to use here. Let's use which one? Let's use this one, BGP. Why not? BGP is always a classic. Okay, so you see here a bunch of sample coding there. You see in all these directories you're gonna see files that have a 10. A 10 means it's a template. Those are templates that I create. All the examples in these directories are created out of a template that I auto-generate. Okay. In this case, I created application 40, 41, 42, 43, 44, and 45. So it seems I created 6 BGP configuration examples using this template. So let's look at create BGP. Let's look at let's do something first. Let's look at the text file. So if we see 40 has 3 files, right? It has a Python, it has a text file, and it has an XML, right? Different extensions, same file name. So let's look at the text file. So basically, this is showing me this is the CLI that is going to be generated by the script, okay? But again, the script is not sending CLI or reading CLI or manipulating CLI. It's manipulating data models in Python objects, okay? But I just put it here as a reference that this is ultimately the configuration that is going to be generated on the box. If I go on the box and I check what kind of BGP configuration this box has, there's no BGP configuration on this router, okay? So if I take a look at the XML, obviously it shows me the data in XML because this application ultimately talks to netconf. It means the data ultimately needs to be converted to XML and sent to the box. So this shows me the XML that is going to be sent to the box. Okay, so you see there the details of the configuration in XML. Okay. If I look at the Python, okay, so all these sample apps are created with the same logic that they have a main execution block. Okay, the script takes one argument, which is the URL of the device that you want to talk to. Okay, it has one optional argument, which is -v or verbose to produce login, and we're going to make use of that to help us navigate. Other than that, the main execution block looks very similar to the example that I showed in the presentation. So we're using netconf as a provider. We're using the CRUD service. Okay, I'm creating an empty BGP configuration. I'm going to populate that in a function that is called config BGP. After I populate that BGP object, I just create that object using that provider on the device. Okay. So if we take a look at config BGP, that's where the magic, a lot of the magic happens. So here's the contents of the function. That is the function where I'm actually configuring the object. Okay. Okay, so it's config BGP, it receives the BGP object, and here's where we start populating the object, and all the hierarchy of this path, of these objects, is a complete one-to-one correspondence to the model. Okay? So let's execute the script. So it's called MC create 40. Okay? And remember, it takes one argument and the URL. So 198.18.1.11 is the box. And it has one optional argument, which is -v to enable logging. So actually, I'm going to enable it so we can see all the stuff that the box or the script is doing in the background, okay? Oh, I forgot the -V. Sorry. All right. So if we scroll up, we see that the script calls the CRUD service using the provider converted my BGP object to XML. It created, at this point, it already validated that that object was correct. Because remember, the first thing that happens is your script is going to validate whether the object is correct. So at this point, it already validated that your object is correct. So it converted this is your BGP configuration here. It converted all that to XML. And it also created the netconf message. So this is the RPC in netconf, right, to do the edit config, okay? So what else did it do? Okay, so this is the rest of the message. It sent it to the box. It got an okay from the router, so that means the router received that request to change the BGP configuration, and he liked it. He didn't find any error. We didn't expect that the router was going to reject it because we already validated the data locally. The script continues sending a commit, because the configuration needs to be committed on the router. And finally, it got an okay from the router. So this is confirmation from the router that it made the configuration effective. So if we go now and we run the same command, we see that now we have the BGP configuration there, okay? So this is an example of an application using a configuration model. I'm going to show you an example of an application reading operational state from the box. So not trying to change configuration, but trying to read statistics and information from the box that is not really configuration, okay?
But you could, if you wanted to, read configuration information to see,
of course,
what's there.
Exactly, yes.
Yeah,
so,
we're faced with stuff like that right now for remediation.
Yeah.
At T-Mobile, and we're having to do screen scraping because this stuff doesn't exist in the boxes yet.
Yeah. Okay. So this is a simple command in IOSXR to see the details of the file systems that the device supports. Okay. So this is what it's telling us: all the file systems, how much. What's the size, how much is free, the different types, the prefixes, okay? So this is a show command. What if I want to recreate this show command? Can I do it programmatically? It's actually fairly simple. Let's look at the sample app for that. So this is the model, okay? And if we look at this sample, oops, sorry. If we look at the script, let's look at the Python code. So the logic is kind of similar. We're using netconf as a provider. We're going to use the CRUD service. We create an empty file system object. We're going ahead and read it from the box. Okay, so we read the file system information from the box. Then I'm invoking this function that is called process file system that is going to take that Python object and it seems that returns a string that I'm going to print. Okay, so this function is the one that does the magic of taking that Python object that was read from the box and it's going to convert it to human readable output. Okay. When we do this read operation, remember, because we're using netconf, it means we're going to read the file system information from the box. This read operation already takes care of validating that that data is correct with respect to the model. The data is going to be received in XML. It's going to do the automatic conversion of XML to Python, so you end up here with a true Python object. This is not a Python object that holds XML. This is a true Python object with the same types as the data model. And then again, this is the function that does the magic of taking that Python object and convert it to human readable output. And if we scroll up a little bit, oops, sorry, I'm in VI. Okay. So you don't need to understand all the details of Python here, but basically what I'm doing, this is the process file system procedure, right? It takes the file system object, and the first thing that it does, it produces the headers, right? The headers that we saw in the output of the show command. And the next thing that it does, it basically starts iterating over the file system, and it starts formatting the output. The size, how much is free, the type, the flag, the prefixes, okay? So let's go ahead and execute it. Okay. Okay. So the output is actually pretty much identical. This is only some additional output that I included that is not included in. If you compare that output to this output, you see that it's pretty much identical.
Can you do the ls on that Python?
Can you what?
Type ls. I want to see whether the XML file got generated. In the previous example, you showed an XML file, right?
You want to look at the XML file that resulted from that.
Oh, okay. Script. So we can run it with -v. That's what you want, right? To see the logging. Okay. So if we go here, we see that when we did the read operation, the script created a get operation with the proper filter for you. Okay. It sent that to the device. The device sends you a reply with all the data, okay? What the library will do is, first of all, validate that this data is correct with respect to the model, decode all this, convert it into a Python object. And then, at that point is when my function was being invoked, the function that would go through the Python object and produce the human readable output. Okay?
So I have a question. So whenever we are coding anything, right? So the requirement will probably come from a network engineer who will give us a configuration in XR format, right? Mm-hmm. And then we will have to convert it into this API. Mm-hmm. Now, is there a way to identify the output that is generated by this API without actually pushing it onto the device, so that we can verify whether we did the right mapping?
Sounds like a dry run feature request.
That's a good question. Typically, what happens is that when you're starting with the data models, you actually have to kind of leverage CLI for some of the validation. And the reason what the natural inclination is to leverage CLI is because of the level of familiarity with CLI. Okay. So maybe initially you wanna put some CLI on the box and maybe read programmatically the XML, right? And have that as a reference, right? To compare whether your script is generating the correct XML or not. I would argue that as you become familiar with that's kind of your crutches to get started. But as you get familiar with the hierarchy of the model, that approach actually becomes kind of a handicap. In the same way that, let's say, when you started learning CLI, you pushed a configuration, you didn't know whether it was going to work or not, right? Over time, you learn the hierarchy and you become really good at sending CLI hierarchies that are correct, and you're very good at, oh, I need to use this show command and I need to verify here, and that's how I know that things are good. Over time, you develop the same expertise with the data model. And the advantage is actually you can do it programmatically. You can create your object, you can send it, and programmatically you can read and do validations, and you can read operational data and validate it, and you can use it to actually iterate very fast. But at least initially, people are still going to find useful to do kind of a combination of maybe I push the configuration via XML and I verify with show run, kind of what I did here, right? I did a show run runner BGP to show you that, hey, the configuration was there. And maybe in a real world scenario, we'll do show BGP summary to verify that, yes, my neighbors are coming up and all that. But over time, I should be able just to do it programmatically without necessarily, the CLI will actually become a handicap.
Okay.
Let
that
me
is
show before I
current
forget.
way of doing that, right?
What's that again?
So in summary, there's no direct way of doing that, no dry run type of a thing that is available, right?
This is an NSO guy, he's used to the dry run command.
Yeah. So that's
a dry run. You're asking about dry run, what would be sent?
Yeah, he wanted to have a dry run where you could generate the XML but not send all the RESTConf, the netcom stuff down to the box.
No, that we have. You can do that. Let me show you. Here. Okay. So the example that I was showing here was with the CRUD service that is about create, read, update, and delete. Another service that we have is the codec service. The codec service, all it does, it takes a Python object and it converts it to different encodings and vice versa. It can take a payload or a string in different encodings and it converts it to a Python object. So to some extent, you can think of the CRUD service has a built-in codec if you want, right? Because every time it wants to send data to a box, it needs to encode it, right? But what if you don't want to send it to the box? You just want to encode it. So that's why you use the codec service. So if we look at the codec service, you'll see here some sample configs. So let's say openconfig, just for a change. Let's look at the openconfig. So let's say I want to see examples with openconfig BGP. Okay, let's look at one of these examples. So this example is a little bit different. We have a provider that is not a netconf because we're not going to be talking to the box. It's a codec provider that we're saying we want to do conversion to XML, okay? We instantiate the codec service. Here we instantiate an empty BGP configuration. We call a function that populates the object with some configuration that I want. And then I'm calling the encode operation of the codec, and I'm saying, hey, I want to encode in XML that BGP object, and I'm printing the output, okay? And basically that config BGP is similar to what I showed before, right? It takes an empty object, and this is populating the object according to the structure of the model, okay? So this app doesn't take any argument because we don't need to talk to a box, okay? So,
and if it generates an XML file, can it be consumed by our netconf provider, direct the XML file?
The output of XML?
Yeah, so the XML file which is generated, can it be consumed by a netconf provider?
Yes, it could.
Okay.
But it will be, yeah, of course it can. But basically what you will do is instead of printing the XML, is you will put it back through the encode operation, right? Because what you did is when you're from Python, you're converting, you're doing encode to take it to XML, and you want to convert it back to a Python object because it has to be a Python object to be able to, what the CRUD service is going to consume is a Python object, right? So you can convert it to XML and you can convert it back to a Python object, yes, of course, yeah.
But you could also take the XML and do it the hard way and write your own code to feed that through your own netconf calls to configure the device.
Okay.
Which is kind of dumb, but it's doable.
Okay, so here's the detail. Oops, sorry, we made a mistake. Let me execute it again. So what do we have here? Basically, we have the result of converting BGP configuration that has been specified according to openconfig. That object has been converted to XML. There are no details of netconf here because the codec service only deals with model objects. Model objects doesn't mean netconf because you can send that object to the box using netconf, or you can use it, you can send it via RESTConf, or you can send it via gRPC, okay? So what you have here is the codification, the encoding of that object in XML, okay? You could save, potentially, you can save this as a template. And one very simple application is you use this as a template, you save it to a file, you read the template, you use the decode operation to convert that XML to a Python object, and then your automation software becomes relatively simple. It's just dressing and customizing these objects. Maybe towards R1, you want to slightly modify the configuration and then to R2, so you do a slight variation on that object and you send it here. But your code becomes very simple because you just have templates in files and you read them, they get validated by the library, you customize them, and you send it to the device.
We're gonna have to cut it off pretty quick here. Is anybody else got one last question?
We have a use case for OS upgrade. I mean, like, we wanted to understand if this can be used, like, to execute certain commands on the device and, like, just to see if those.
So the question is, could you leverage this to maybe do like a operating system upgrade? I don't know, maybe an ISSU sort of functionality.
That's a pretty good question. So upgrades, software upgrades are actually. Let me see if I can get this back in. If you remember, at the very beginning, I said data models basically are going to define configuration, operational state, and commands that you can run on the box. One of the commands that you can run on the box is to install software, right? Install, okay? It's not the only command. You can do a ping, right? You can do a ping on a router. You can trade. You can do MPLS. Optimizations, right? There's a lot of stuff you can do. This is the area where I said there are some gaps in model coverage. So install today is one of the models that we haven't implemented yet, but we have it in the roadmap. I would probably say in the next 6 to 9 months, we should have it available. You will have a YANG data model, and you'll be able to execute installs from YDK. Today, for instance, you can do a ping, you can do SNMP, syslog messages, like a custom syslog, I think. I forgot the name of it, the command. So install is something that definitely you should be able to do, but it's not something that you're able to do today. It's probably coming in the next 6 to 9 months.
All right.
Any questions?
Santiago, thank you very much. This has been very good. Like I said, I've been excited about this particular direction that the industry is going and your tool, and I can't wait to have YANG data models ubiquitous throughout our network at T-Mobile so that I can leverage this. It's just that it's going to take a while, but I'm anxiously looking forward to the day that I can really leverage this in production. So thanks for the presentation, and unless you've got anything else, we've got a drawing that we've got to do, a couple of closing things, give away a couple of books, and I think there may be a couple of announcements, but that's it. So, again, we'll let you go. Thank you.
All right, guys. Thanks for the invite.
Okay, so those of you that stuck around,